Okay, so good evening, ladies and gentlemen. Today we'll just continue from the previous, and now the main idea is just like how can we apply the little things that we can know. How can we apply to solve some certain problems or some certain issues using CDO, but before we go to that, today actually we will try to see like how can we. The main target today we'll try to see how can we calculate things like bias. Okay, how can we calculate things like bias? If we use some mathematical or statistical commands which are there, how can we calculate like bias? Okay, or the difference. In short, it's just like the difference. Maybe you have two data sets. Okay, maybe between the model and the observed. Okay, and observed. So how can we calculate maybe the difference? What is their difference? That's the target we'll try to do. Yeah, so it cannot always be a model. Maybe this one can be a forecast. Okay? For those who do forecasts, you can just imagine like it's a forecast. So you want to check, you want to compare. Maybe what are the biases? Okay, if you compare your forecast and the observed, what is the bias? Is it overestimating? Is it underestimating? Okay, so we'll try to do like that thing. That will be the main target of today. So generally we just make use of the things that we already learned, like maybe subtractions, additions, because for example, if you look at, if I'm not mistaken, generally, if you want to check the bias is just the difference between the model and the observed, not so, or the simulated and the observed, or the forecast and the observed, of which we can write like, if you have observation maybe for a longer period, or your focus is for a longer period, okay? So to check the bias, generally, if you are using the mean bias, okay? If you are using the mean bias, it means you have to calculate the average for a certain period. For example, you need to calculate maybe the mean, okay? Which is model minus observed, okay? Which can just be mathematically expressed like this one. Like this one is just like, it's just the bias between the model and your observed, and you are calculating the average bias or the mean bias for a longer period of time. Okay? So how can we calculate such things in CDO? So we just make use of some mathematical commands in CDO. In CDO, we can use those things. However, when you're comparing maybe model and the observed, or forecast and the observed, there are some things that maybe you need to put in mind. One of the things is that you should make sure that all your data has the same resolution. Okay? All your data has the same resolution. For example, if your data has, your model is 1 degree, okay? If your model is 1 degree, and your observed maybe is 0.5. 0.5. So, first of all, you have to regrade them, okay? You have to regrade them, like, maybe you need to put either this should follow this, it's up to you, okay? Either this should follow this, should be 0.5, or you can make this one also to be 1 degree, or you can make them to another resolution, okay? You can make them to another resolution, but it should be standardized. They should have a standard resolution. So how do we make them to have a similar resolution? How do we make them to have the same standard is what we are doing last week to regrade the data. So before you do this, you have to make sure that your data has the same spatial resolution. If it is having different spatial resolution, CDO will refuse. CDO will refuse. It will not calculate. It will tell you that the data have different spatial resolution. I hope it is even in other softwares too, like Python, I think NCL, all of them you have to regrade them so that it can calculate the difference, the bias. Actually, it's not even only the bias, but all evaluation metrics. You need to make your data to be on the same spatial resolution. So if we can be able to do this thing, if we can be able to do this one, it means we can be able to do the rest metrics, such as maybe you want to do the normalized mean bias, you want to do like the root mean square if you're comparing your data sets. You can, if you can be able to do that, then the rest you can be able to do. The rest will be much more easier. However, there are a few things that I did not mention last time. So before we go to that, I'll just make a quick review, or I'll just show how you can do them. For example, okay, for example, when you are downloading the data from some sites, okay, they will not give you data sometimes in a single file. Sometimes they may give you multiple files, maybe different years, or even months, or even maybe days. So you need to merge them, okay? Those things you'll be finding the match. You need to merge them into one file so that you can work with it. So in CDO, you can do it. You use merge, the command merge. Use the command merge. You can merge your files into one file. If you have so many multiple files, okay? Let me just give you an example of how it works. I will use the same data that we have. So, let me just create a folder here. I don't want to have so many multiple files here. Okay, so, I'm sorry. In Linux, you can also create a folder, okay? You can just create a folder. We use a command, what we call mkdir, means like make directory, okay? It's like make directory. Instead of going to the Windows, right click, new, what, you can just write mkdir. You can create a new folder like that. When you be working with Linux, you'll be meeting such things. But we are working in Windows, so we will not use much of those things. We will not use much of those things. That's why I did not mention it. So let me just transfer one file. For example, which one should I transfer? Okay, I'll transfer this one. Let me try. Okay, so the folder that I created, you can see it has appeared here. Okay, when I just slide mkdir, then on Windows to also apply here. Let me try to transfer this file into this one. Okay, yeah, let it be there. So, then I can go to that folder, CD, and, okay, LS, okay. So, I don't have data sets. I did not bring data which is in many years, is different files. So, I will just split this file. I'll just give an example. I'll just split this file. So let me split CDO. I will split it into years. CDO, okay. Split what? Years, okay. Then I can put my input file, okay. Let me just label it as Y. When we are splitting Cs, split years, it's okay. The output file, you can just give it a name without .nc. It's okay. But if you are making calculations, make sure your output file we should write .nc. Okay? So, what is it saying? Not, what's the problem? So, you see, CDO is suggesting for me. We won't have inter-year, cell-year, so what, split day, split RAM, split what, split C, split up to split year. So what's the problem? Yeah, so we don't have years, we only have year, split year, okay? So that's the goodness of CDO. It will suggest for you, like, are you trying to do this? Yeah. So it means I have to modify here, I have to remove S, okay? Okay, then it will start splitting. Okay? It will start splitting. The file is big, so we can wait a little. We can wait a little. Actually, I shouldn't have splitted this file. This file is very big. For you, can you try to split the file for Mela? Because it will be very big on your computer. It will be very big. So you can try to split the small file, maybe the Mela. Okay, it is done. Okay? So if I go into my file, LS, you can see I have data in years. You can see maybe year 2011, and it has automatically brought .nc. So when you're splitting, it's okay, it's fine. Don't write .nc. You can just write one. So it has brought the .nc. Now, so you can imagine, then I can delete this file. So I will delete this file first, okay? I will first delete this file because I want you to assume that you downloaded your files, but they came yearly, okay? They came yearly. So you can imagine that these are just the files that you got them from internet. So you want to merge them. You want to make one file so that you can be working with it. Okay? So in CDO you can merge. We use a command called merge. So since they are of different time, yes, so you can use what we call merge time. You can use merge time. Okay? Like here, if you do CDO, if you are lost, remember -H, if you are lost. So I can just write -H, then merge, okay? Merge. It will give you your options. Is it just merge or is it just merge time? Okay? So we'll be using merge time. We'll be using merge time because we are merging files which have different time. So we want to put them together. So what we do is, you write CDO, what you can do is CDO, merge time. Merge time, we are using the second one. We are using this one. CDO, merge time. Initially, we are supposed to write our files, okay? We are supposed to write our files. But if you have many files like that, you have downloaded many files, you just need to write, if you write merge time, you need to write, you need to write a star, okay? then dot NC. Merge time space, okay? Merge time space, then star, okay? Star dot NC, okay? So what does this mean? It means you are telling CDO to say, can you merge all the files which have .nc, all the files which are ending with .nc. That's what you do. So you don't need to type all the files which are there. So if you want to merge the files, but there is one file that you don't want to be merged, it's better that you should remove it. Because here, you'll be merging all the files that ends up with netcdf. So when you are merging, it's better that you are sure of the files that you are merging. Okay? You are sure of the files that you are merging. Yeah, so here I'll be merging all the files which ends up with .nc. And there are those files that I splitted, okay? There are those files that I splitted. Or maybe if you have some files, that maybe they have another prefix here, okay? You can just follow the prefix which is here. If there are multiple files, for example, maybe there is one file that ends AB, maybe AB.nc, okay? But you have even other files. Okay, actually here there are many files that ends with nc. And you have one file that maybe ends with bc.nc, okay? And you don't want this to be merged, so you can just write the one which have this prefix. The idea is just to show I want the files which are on this group, or the files which have this name. That's just the idea. So you can give the output, you can call snu2.nc. Now when we are merging, we have to put .nc. It's different from splitting. So here I have to put .nc. I don't want it to. Oh, you can create another folder, I think. You can create another folder because I didn't want to have many files in this folder. Okay. Yes, yeah, it will confuse you later. Yeah, so when you want to do this, try to create a new folder so that you should not have many files in one, and it will confuse you to merge because there are so many NCs files in the previous folder that we were using. I hope you understand why I created a new folder. Because when I am merging, it will merge everything which is netcdf. So I don't want to take everything which is netcdf from the previous folder. That's why I've created a new folder just for example that you are merging your netcdf files. Okay? You can imagine previously my folder was this, okay? Not so. Which means that in this file, I also have these netcdf files. So if I split my data in this file, in this folder, it means when I'm merging netcdf files, I'll be merging everything which has netcdf. So I don't want that. I want only the data that I'm splitting. So that's why I've transferred separate file, so that I should not be interrupted with these ones. Okay? However, still more I can do that. It means if my files here are ending with dot has y something. It means I can just here write everything which has y. However, it will be complex if I still have other files which have y inside here. So that's why I just transferred to a separate folder. Yeah, so that I should have a clear folder that with no any disturbances. Yeah, so from there you can merge your files. You can see it is trying to merge. It's giving me some warnings, so you can disregard those warnings. Okay? So it is trying to merge my files. So if your files are very big, for example, you are merging daily data, global, it may take some time. Or if your processor is very good, your computer is very good, then that's okay. Like this one now has finished, okay? So if I do LS, I have that system2 file. You can see it here. I have that system2 file that I generated is this one. I deleted at first, but I have regenerated it. Simply, it just means that if you have downloaded your data, you can merge it. If you have different multiple files, you can merge them together and work with that file. It's just like a backward process, like what we were doing last time. We are splitting, but now you can combine them. Okay? Yeah. So you can merge your files like that. Okay, so I think I can delete these other files because maybe I don't want to have space issue. So if my space is not enough, I can just delete. This is just for practice, okay? Later on, you can work on your own data, download the data, try to merge it. So there is another merge, okay? For example, you have wind, okay? For example, you have wind, you have temperature, and you have rainfall. You can as well merge these files together in one file. You can as well merge them together. So in this one, it will not be merging time. You just use merge, okay? You just use merge. But they should have the same time range, okay? They should have the same time range. You can't merge the file, maybe one is from 2003 to 2005, which is temperature, and then you are merging with rainfall, which is from maybe 2010 to 2011. If you are merging such things, they should be of the same time, okay? They should be of the same time, and also maybe same area coverage, Why is it important? It is important because there are some softwares, when you have a merged file, you work them easier with, okay? You work with them very easier. For example, when you are learning GrADS, okay? GrADS. We had a file that we were displaying wind, then we were overlaying pressure. It was in the same file, okay? So if you want to work in the same way, you can as well merge your file. So use the command merge, okay? Use the command merge, this one. You only use this one, you don't use merge time, okay? You just use only merge, this one. But your data should be of the same area. The area should be the same. The area should be the same, and the time should be the same. The other thing, last time I did not touch on, I just want we should have a quick review is, you see this file, for example, let me delete these other files. LS, okay, if I do CDO show var, if I do CDO show var, wow, this has so many. Okay, we should not use this one. We should be able to change the name of this variable. How can you change the name of the variable inside the data? Okay? Because sometimes you'll be finding that you download some data have very long names, okay? Very long names. So for you to be typing one and again, you can just modify the name in that file, inside that NetCDO file. You just put a short name, okay? You can just put a short name inside that file. So we can as well do it in CDO. We can as well do it in CDO. So I want to use a file which has only one variable, not many variables. For example, let me try on Mela, okay? Let me try on this one. Let me put in this folder. For example, CDO, show var, I want to check on Mela. Okay, show var. Okay, yeah, for example, the name is BCS mass. This is the name inside the data. So we want to give it another name. We want to give it another name. Or when you are displaying in GrADS, we display this name. When we say D so, we use this name. So in some data sets, the names are very long. Okay? Very long. So you can shorten it or you can give it another name. Okay? For example, in CDO we use SH. We use the command SH. So it can be SH name. It's like change. Like change name, change unit. You can change the units in the same way. Okay? So for example, in our data we can do CDO. Okay. Or you have forgotten, you can ask CDO minus H. Minus H, just write space CH, okay? Name. Why is refusing? Oh, okay. It's not giving me the help. Okay, it's fine. It's saying the operator not found. Yeah, like this. So you can see about SH, the command SH, so there are many. So maybe you need to change code, change parameter, change name. For example, this change, they want to use change name, want to modify the name. If you want to change the units, you can also change the level. Yeah, so there are many. So we want to change the name inside the data. We want to rewrite the name inside the data. So we are using Mela. Yeah, so you do CDO, CH name, okay, or change name. You put a comma, okay? You put a comma. And you copy the original name. First of all, you copy the original name. So the original name was BC mass. Okay, and then you give it new name. You give it new name. Okay, maybe we can just label it BC. We can shorten it to BC. Okay, then input file. So we are using Mela. I'm too fast. Oh, this one? The code, I'm still writing the code. Okay, so you can just write the recording. There is no internet. Yeah, so you can just write SH name, comma, the previous name of the data, then the new name you want to give, in file, then out file. In file, then out file. Oh, the step before one, just do CDO show var. You want to see the variable name? Yeah, just do CDO show var, then input file. CDO show var, then input file.
That's the variable.
That was the step before. We wanted to see what is the original variable name. There's internet problem. So here we always use the internet? For it to be seen here is internet. Okay, we are just having a few problems with the internet, so we're trying to resolve it out. CHS. Yeah, the command is just like this. And just do like CDO. So the command can just be written like this. You write sh name or chi name xt. So this is original name. This is original, and this is new name. This is the new name. Is it working?
Yes, you've left me behind.
Great. Oh, it's in. About the data. Do you have the mail data?
Yes.
But he has not opened the folder where it is. That's why it's where it is. It's this one.
Yes.
Okay, then you just press it.
Are you able to follow? What is the problem?
Change the name.
Change the name. Let me come that side.
Then after new name is
I'm stuck here.
Where?
I've created the folder and copied the.
Yeah, you can just copy Mera or just copy Mera. Copy Mera, the small file. I used Mera because it was small. This was very big, so it takes a lot of time to process. Yeah, you can just put Mera in that folder and then.
changing the name. So CDO,
SH name.
CH name, then the
Comma.
the
Old name, which was BCS mass.
okay,
You can first view the previous name. You can do CDO. First delete those ones.
so delete this one.
Yeah, delete everything. And just do CDO.
Okay.
Show var. You first need to see the previous variable.
Yeah, I've already done it.
You already did it?
Yeah, that's the BCS mask.
Yeah, BCS mass. Yes,
I
yeah.
want to change it.
Yeah. Okay. Then you can do SH name. Yeah, CDO SH name.
Okay.
Then comma. Yes.
BCS mask.
Yeah, I think it's capital letter.
Yeah.
Yeah, and then you can give it a new name.
So after new name,
You give it a new name.
space new name.
Yeah, you can give it a new name.
After new name, what?
After a new name, they just put in file, out file. In file is mirror, then out file, you can give it any file. It's a little bit complex.
I just during splitting, a lot of things happened. It's very long.
Oh, which file did you split? Assessment. Yeah, it's okay. It's okay. You what?
So mirror is the in file, then the out file.
What command did you use?
To split? Just
Did you manage? Did you manage?
Yeah, so mirror is the in file, then the out file can be any name.
You can give it any name.
Okay, so mirror 2 underscore out dot nc.
Okay, I want to see the command that you use for splitting.
Can I ls right?
Splitting. Yeah.
ls to this.
You do CDO.
Okay, I've changed the name CDO.
CDO, then show-var.
Super the variable, right?
Oh, you splitted months. You should have just splitted years. So these are months. You have split all the months which are there. They are months now. So you can merge them again. You can merge them.
okay. When I'm not saying at this okay. It doesn't say
.nc, merge time, .nc, then give it a name. So now, you remember you already have another file called sys.
yes.
So we don't want that to be merged. You can either maybe remove that file.
Okay.
That's why I created a new folder, so that I didn't want to disturb it. So you can just create a new file. Yeah, so you see there, if you write .nc, it will merge all these things. So that's why I created another folder called start. So that, so maybe what you, no, don't delete this one, because if you delete this one, so you can just maybe copy this one. You see, these ones you can just cut them. Yes, and create a new folder and paste them. Create a new folder and paste them. That's why I created a new folder.
Yes, split here. Split. CDO split here.
CDO, CH name, Mera2, then I give the new name as Mera3.
Okay, so here when you CDO name here,
Yeah,
this name is the name inside the data.
this one.
No, not this one. No, not this one. Can you do?
From the file,
Files are confusing. What they are confusing is how to play with the files because we have several files. So we mix files. That's the problem.
Okay, the files here, you can choose any file, is not a problem, but what I chose the file because the other file was very big. So I chose mailer, which was smaller file.
For instance, here,
wait, first, let me this one.
in the same case, I've chosen a mail from here. You can see. I want to rename it as to be Mera maybe 3.
Okay, so, okay, let me clarify something. When we are renaming the files, we are naming inside the file. There is a variable that we display.
From the file path.
So it's the one that we modify inside, not inside the data, yes. There is a variable name that we need to modify. This one you can just rename even in the folder there. Manually you can rename it, but inside the file, for example, here you can rename anywhere here, like Mira you can name, but we need it inside the one we do display. The one we say D something in GrADS. For example here, can you come here? Do CDO, space shover.
Okay, so
Space. Mirror.
okay,
Just press tab. Oh, no. Okay, continue .nc. Mirror.nc.
NC.
Enter. There is no file search file. You do have Mirror 3?
No, haven't.
Yeah, I put Mera 2 to show her. What I got is here.
It's the same.
Same case I.
Yeah, this is the name I'm talking about, BCS. It's the one that we are modifying.
So we are modifying this one.
Yes, we are modifying that one. Yeah, we are collecting that inside the data. Yes.
This one.
Can you let me see?
This is my folder.
This is your folder.
It's not all file.
You can view any of this one. You don't have Mirror file.
Yeah, yes, this one.
You don't have Mirror file.
Open this one. Open. Yeah, open this one. Yeah, open it. This is Mira. And again,
This is not, is it extracted?
yeah, extract, I did from, extracted from that.
Oh, you have a folder called Mirror.
Yeah,
Okay, you can go to that folder. You can just do CD, go to Mirror. You have some challenges? You have some challenges? Okay, I'm coming.
In that command for changing the name, after the new variable name you want to say, there is no comma. If you put a comma, it cannot operate.
Yeah, there should be a comma, yes, yeah. There should be a comma, it's fair.
I tried to do the comma then that's right, but I removed the comma. It's done. After T.
After T?
Yeah.
Oh, yeah, after T there is no comma, sorry. After T there is, you are right. There is no comma after T. You are right.
Can you check mine why it is not reading my file? It did last time, but it's not reading my file. This is my file path. The training seems to give it, but it's not following it. Maybe I'm doing it wrong.
Let me see, where are you?
Oh, I did it before.
LS, you need to go to this part.
Yeah.
Yes, so it's this one. You just need Control C. Then you come here, CD, space, MNT, like this. Then you paste that thing. You remove this one, you make them forward slash. This one
I didn't
also.
know the pasting thing.
This one also forward. Okay, I've deleted something, but you need this capital T. This one can be a small d. See, like that, and then you can do LS. So you have your data.
First, I splitted my data. Then now I want to merge them.
Yeah, do CDO.
Okay.
CDO. CDO.
This is
Make time.
okay time.
Yes,
I only
make time.
said merge. So did I get to put the star or it's not important?
Star.nc.
.nc.
Yes. Remove that. Just don't put space. Star.nc.
Then I will now give the
You can put its name.
okay. So I decided to put merge.nc.
Make.nc. Do you have the system file inside that?
No. Only this.
You deleted the decimal file, only the splitted.
Yes, only the split.
Yes,
I copied the decimal file into the star.
Oh, okay.
Split it inside. Now I want to merge it inside.
Okay, you can make it.
Thank you so much.
What's the problem?
The network is now seeing the WeChat.
Here we don't have a projectile. Yes, sir.
Want to change the name here we are. In CDO. Change what?
Change name. Chinam.
And it is similar.
Not fine. Hey, sir. There's some problem of internet here.
Yeah. That's a problem.
Yeah, sure.
The digital thing is disturbing us.
I see, I see. At the end there, yes, yes. There is no direct connection?
So just continue.
Yeah, we can continue.
So the break is end. Can we continue? The break is over.
Should we proceed?
Let's proceed.
Okay, so I think these are not big issues. I just wanted to show you that you can modify the names inside the data. You can try to collect it. If your name is very big, you don't want to have a very long name. Like this becomes important. Like maybe you're using other softwares, like maybe Python. You don't need to have very, very long names. Okay, you need some short names. So you can process when you are processing your data in GrADS, you can try to correct such small things before you proceed. Does it work? Are you able to do that? Okay, if you're able to do, okay, that's fine. Now, let's go to our main task of the day. Let's go to our main task of the day. Okay. Go to the folder where you have all your data sets. The one we were working last week. You remember the folder? In your computer, go to that folder where you have all your data sets. Like me, I have all my data sets in this folder. You just do CD CD ... Hey, I have to be talking both like the Linux language. So if you do CD ... like you are moving a step backward. Okay? Change directory. This is CD change directory. You want to move backwards. You just type ... okay? You just type ... and then you can do ls to see where you are, to list the files in that folder. So you just type CD ... So you remember the conditions. You remember the conditions. For example, we want to check the bias between two data sets. Okay? We want to check the difference. So we said the data should have the same resolution. Okay? The data should be of the same resolution. Did we regrid our data last time? Did you manage to regrid your data, or we should do it again? We do it again, not so? Okay, so let's do it again. Do you remember how to remap, Bill? Or do you remember how to do the grading? Let me recall the command. No, I don't have it here. The owner did a lot of things with the computers. Okay, so you can do CDO. CDO, can you regrade the file? Can you regrade the file called what? Can you regrade this? Yes, can you regrade this file? Do you have this file? Do you have it? Or you are using your own file? If you are using your own name, then you okay, let's just start from the beginning. Yeah, if you are using your own file, then we can just start from the beginning, it's also fine. We'll start from the SESM2 file. Yes, we'll start from the original SESM2 file. That will be much more good. Yeah, so it means let me also clear some of my files here. Okay, thank you. Or do you have the file for Africa? Do you have the file for Africa? Okay, if you have the file for Africa, much better. We can start from there. Because the SESM will be for global. Yeah. So we start from SESM. Go very far. Some people want to start from SESM. So okay, we can start from SESM. Okay, no problem. No problem. So the best way then, let's create a new folder so that everything should be clean. Yes, let's create a new folder so that everything should be clean. So, or you can use this same folder we are using. Create a new folder. Okay. I think mine I deleted. Yeah, so put SESM file and Mela file in that new folder. Mela and SESM too. Okay, you have those files, two files, Mela and SESM2. Okay, then go into that file. Okay? You go into that file. So, we want to calculate the difference between the model and the observed, or reanalysis. So we are using reanalysis because we don't have observed. So we'll take it as an observed. Yeah, reanalysis. So Mela is the reanalysis, okay? So we have the conditions, okay? 1, we said our data should be of the same spatial resolution. Of the same spatial resolution, and also time should be the same, okay? The time should be the same. The region should also be the same, okay? The region should also be the same. So let's check our files. How do they look like? So how do we check them? How do we check them? Because that's the first thing. Before you start processing your data, you have to know your files. What are your files like? Okay? So we said it's what? CDO? Okay, let's start with what says. Okay? Okay, so this is our file. I said create a file and copy SESMO file and Mela file. Because we are starting again from the beginning. Okay? So we don't want to have already many files inside it. Do you have those 2 files? Okay. LS. I will do again LS. You see in my folder, I have 2 files. SESM2 and what? Mela 2. Do you have those files? Copy them and put in a new folder. There should be only 2 files in that folder. I don't want disturbances with other files. Just transfer them in a new folder. I don't want any disturbances because some will be lost. You'll be saying you have many files. Anyone who is lost? If you're lost, don't worry, we'll wait for you. Yeah. Yeah, you can check both of them and compare what are the differences. Yes. Okay, do we have them? Can we see the information for the SESM file? So, okay. You can see this data is global, not so? It is global or not? Huh? The SESM2. Can you SE for the SESM2? Okay? You can see that our data is from -90 to 90. This is the resolution in terms of latitudes. Okay? And 0 to 358, and this is the resolution in terms of what? Longitudes. Okay? And it has 2 levels up in the atmosphere. 180 times steps. Okay? And the years is from what? 2010 to what? 2024. Okay. Now, let's go to Mela, okay? Let's go to Mela. So, remember, we are using Mela, okay, as a standard, or we are taking it as observed because we don't have that observed that can have a spatial coverage, okay? Yeah, so let's check it. So let's do CDO. CDO what? Okay. Actually, you know, these are the things you'll be doing when you are doing your research. So don't overlook on them. You'll be meeting them. You will not skip on this, especially if you are doing some data evaluations. So make sure you are able to view your files and understand what you are doing. Okay, so if we look at Mela, okay, how many levels does it have? 1. It's only one level, it's a single level. Eh? So you have to see that you can't compare two data sets, one with so many levels, then another one level. It means those conditions now have to make them same, okay? It should also be single level, okay? Now let's go to spatial resolution. What is the resolution of this data? What is the resolution of the data? 0.5 by 0.5, not so. The other one was what? The other one was what?
1.25.
Huh? We start with which and which? 1.25? I think let's start with LAT. LAT is what? 0.94 to what? 1.25. Okay, so these are the spatial resolutions. They are different, not so. So we also need to make them what? Same. Okay. So on the spatial resolution, I think the best way is just to transfer this one to this one. Okay? Yes, you just transfer this one to this one. Make this one also be 0.5 by 0.5. That will be much more easier for you. In some data sets, in some analysis, the way you want, you can all make them to different resolution. Maybe you want them to be maybe 1 degree by 1 degree. It's up to you. Okay? It's up to you. But for our case, let's just use this one to be 0.5. So that our standard data should be 0.5. And also our model is what? 0.5. So that we can easily what? We can easily compare them. I hope it is clear there. Okay? And also the levels. This one has a single level. Okay? So we should also use one single level to compare. The second thing is, you see the time. This is from what? 1981 all the way to what? To 2014. Okay? But if you look on this one, it is from 2010 to 2024. So which period can we compare? You look on your data, like our data, this one is from 2010 to 2024, okay? And this one, the second one is from 1981 to 2014. So which period can we compare? Huh? 2010, 2014, eh? Okay, it's like we have two data sets and they are meeting between 2010 and what? 2014, yeah. So we are comparing this period they are meeting, we can do that. Okay. Not always it will be like that. Okay, this is just an example. Not always to be like that. Sometimes you can have the data all from 1981 to 2024. You can choose your own period which you want to compare. Whether you want the entire period, you can also do that. Yeah? But some work with big models, like global models, Earth system models, like maybe CMAP models. They have data sets from historical time, 1850. So you can't compare your data all the way from 1850. You can just choose a certain period where your observed is covering. Okay? Yeah. Okay, so first of all, we need to make this data at a single level. Okay, so these are pollutants that I would advise you just we select the lower level. Okay, because most of the times pollutants are concentrated in the lower level. So we'll just select a single level. You remember how to select the level? Do you remember? So we have to use all the skills that we have learned them previously. We have to apply them here. So which one are we selecting for single level? This one, not so. Because this one has many levels. The seismic data has many levels. And is the one that we want to compare with the what? Reanalysis. Okay? So let's select a single level. We select in the lower level. But first of all, let's see what are the levels. Yes, first of all, let's see what are the levels. So we do CDO. Show what? Show level. Level or level in full? EL. Oh, okay. Then we are checking for seismic. You can just press tab, okay? And then you do enter. It will show the levels. Okay? So remember, these are these are pressure levels. So if you see the higher value, it means it's lower in the surface. On the surface, remember it's what? 1000 what? HPA. Okay, remember? Or 1000 millibars. So the higher the number, it means it's on the lower levels. So let's select the lowest level. Our lowest level is what? This one. Okay? You can copy this one. Okay? And then we only select this level. Let's do CDO. CDO. CDO what? Cell level. Okay? Then you write, you put a comma, you put your number. Okay? Our input file is what? Seismic. Okay? Then you can give it another name, maybe just write level 1, so that we know that it's first level. Okay? You can write .nc. You can give it any other name, but you have to remember those names. What's the problem? It's giving me some, saying what. Mine is refusing. What's the problem? Huh? What did I miss? Operator not found. What's the problem? Huh? This one, not so? Okay. So is say what? You should remember them, yeah? The cell level, okay? And the goodness CDO suggests for you, not so? So set level, you have cell level, it is here. So CDO suggests for you. Okay, we do again. It has processed. Okay, you can first do for you. Is it working? Anyone with a problem? Anyone with a problem? Okay, I should be giving you time so that you should not be writing, you should be typing. I will wait for you. This one, I just load Sesmo level 1. I just saw Sesmo level 1. Yeah. You can give it any name you want, it's okay. Huh? Or you
Information, you know.
Information are not there, but and I put the value then.
huh?
Yeah, I get the values as, but I just
It's okay.
yeah, it's okay. We can end up with differences figure.
Can I do?
Yes, I do this one.
Oh, you mean the size?
Yeah, this one.
I think it's okay.
It's okay.
It's okay. I think it's okay. Should we proceed? Oh, okay, I should wait. Anyone with a problem? No problem? Yeah, you can help him. Can you help him? I'm lost. I don't know where I am. Do you have these two files, Sesmo and what?
Yeah, I have them. It's in the capital.
Oh, let's make it small. You have those two files, I see them. You have a problem? Oh, okay. Okay, then let's proceed. So we have selected at a single level, okay? But how about the years? The years still remain not so. So we also need to select the years, okay? So do you remember what we did? CDO? CDO what? We first need to show the year, or we have already seen the years up. We just need to select them. Okay, so let's select the years. Okay, so CDO serial year. Okay, CDO serial year. Then what? We need to put a comma. We need to put a comma. 20 what? 2010? 2014. Okay? Then, which one should be our input file? Which one should be our input file? Yeah, remember now we are moving with this one. Okay? Okay, so what name should we give? We can give it what? Oh, okay, we can put 2010, 2014, .nc, okay? Okay, we are giving that name. Okay, we do enter. Okay, let's see the years if we have already selected them. CDO what? Show year. then 20, okay, this one. Yeah, so we have the years what? 2010, 2011, 2012, 2013, 2014. Okay? One processed one variable at yours is also having one. Why mine is having one variable? Let's see what are the variables inside this data. Or I'm processing wrong data. CDO show here. Oh, show var. Okay. What variable do you have in your data? BCF4, not so. Are we all having the same? Huh? Oh, okay. So this is the name we are saying we can modify. If you want to change it just to BC, you can modify it to BC. So this is the name I was talking about. Okay, so now, this data is on 2010 to 2014. Okay? How about Mera? How about the Mera data? The Mera data? See your Mera data, okay, CDO show here, or just S info. Show info, S info. Okay? Yeah, you can see the Mera data is from 1981. So we should also make it what? 2010 to 2014, okay? Yeah. I'm sorry, the process of typing is, but that's what research is all about. Okay? Later on we can script this thing, we just do it at once, but I don't think we should go that way. We should at least learn, we should know what we are doing, okay? Yeah, I don't want we should just go straight scripting everything, one command. No, let's learn step by step. So, let's also make Mela have the same time period, not so? Okay, so you just use this command. You just use this command, okay? This one. Yeah, you can just recall this command, okay? And then you just change here. You just change on your input data. You put Mela, okay? And even the variable name. So what should we label it? What should we label for Mela? We can just add Mela in front, not so? Or at the beginning. Or you can write it here. You can write it at the beginning, okay? Okay? And then you can just press enter, okay? If you press enter, you can see it has processed the values. So if you check, I am moving very fast. Okay, first can you process the one for Mela also to have 2010 to 2014, the same as the one for model, the one we have written 2010 to 2014, okay? Should I continue? Have you processed the Mela data?
What about the levels of Mela?
Mela is only on one level. Mela is already on one level. Okay, you can just verify. You can just verify CDO, S-info. You copy. You use this one, the one we have just generated. Mela 2014. Okay, it's from 2010 to what? 2014. Not so. It has 60 time steps. Over 60 time steps, variables over 60 time steps, okay? Then let's also verify that other one, CDO 2010, this data, okay? No, I did not do a info, not so. Okay, so you can see it has 60 time steps. And also this one has what? 60 time steps. So it's from 2010, 2014. This also 2010, 2014. So we're trying to standardize our data to make it should have at least the same feature. What else have we not done? Someone is asking of level. So level for Mela we said is already at single level, not so. For example, here, the Mela is this one. Is already at level 1. Only one level. So the other one too, we standardize also. It is also at what? At single level, level 1. Now it is also at level 1. So the levels we have made single level, single level. The time period is also now the same, not so. But if we look at this one. Can you see the coverage? Okay? The coverage is from 0 to what? 380. Okay, at this resolution. How about this one? It's from minus 28 to what? To 60. And I said to 60. So let's also make the same resolution, not so. The same coverage, not so. Okay? We should also make it the same area coverage. Okay? So, can we cut this data to this resolution? How do we do to cut to this to Mela resolution? What do we use? If we want to cut our data, we are saying, okay, let me write here. The one written Mela 2010 to 2014. What is the coverage, area coverage? What is it? Can you check in your data? Can you check using your data? It's from where to where? This one, Mela 2010 to 2014. The one you cut from, the one you processed from Mela. Can you check? Huh? Minus what? Yes, minus 28 to 60. Okay? So this is LAT. Loan. How about LAT? 45 to minus 45. Either can be this way or this way, is also okay. So those are the coverage. What about the model? Model is what? 0, 2, 3. Oh, okay. How about that? To 90. So we need to make them same region, okay? So we need to take this one to this one, okay? So how do we do? Do you remember the commands that we did? So make sure you have to recall. You remember last time I told you, each command, you should be able to understand where can I use it, okay? You should understand where can I use it, why is it important. So how can we cut a region, okay? Yeah, so we need to do CDO, cell, loan, lat, box, okay? So lat box, comma. Minus 28. I'm not very much sure, like after we regrid, are we still going to get minus 28? I'm not very much sure. So first of all, let's put at 30, minus 30. Yeah, just extend a little, put at minus 30, okay? I'm really not sure after regrading, are we going to get the same minus 28? So let's just extend in case. If it is much higher, we'll reduce it later, okay? So it's minus what? Let's put at minus 30. So it will be minus 30, comma, 60, comma, 45, minus 45. Yes, remember to start with a small number. Okay? Minus 45, then 45. Okay? So we are cutting the model data, the one we generated from. Yes, so let's cut that one, this one, okay? Let's cut this one. Yes, let's give it output name. Yeah, it ends with .n, oh, .ncc. This region is in Africa, so we can just put it maybe Africa. Okay? We can just give it a name. Okay? Okay. Then you can process it. So the one we are going with now is written Africa. I didn't finish it. I didn't finish it. Okay, when you're typing later on when you'll be coding, sometimes such things to be typing full names, you find like it's taking long, so you can shorten them. I just shorten them. Okay, so we can try to do CDO, S-info, free. Okay, so we are at minus 30 to 60, minus 44, whatever, 44, this, okay. So let's try to, what next? So the region is almost the same, and the time is the same, okay? The level is also single. What else has remained? Spatial resolution still remains different, not so? Yes. So the spatial resolution is still different. Let's try to regrade it. We said we should make it to what? 0.5. We said 0.5. So how do we regrade the data? You remember? Oh, you have forgotten. Okay, so let's try to regrade the data. So we said first, We should generate a what? Yes, we should generate a grid file, .grid. Okay? We will use which data to generate it? Yes, we should use which file? We should use our standard data or observed data or reanalysis data. Okay? The one that we want to get its resolution is the one that we should generate a grid file from. Okay? Yeah, I hope that is clear. So we can do CDO. How do we do CDO? Grid. Grid what? Okay, then input file not so. Is there any comma here? No comma. You people, you don't remember. Huh? There is no comma? Oh, okay. Okay, so what is our input file? Oh, Mela. We said Mela. Okay. So we said we use this arrow, not so. Is it like that? Oh, yeah. They are saying we should use Afri. Was that Afri for Mela or for model? Yeah, we don't need to use. We should use Mela, not so. Yeah. Okay. So let's get it from Mela. Yes, and we just use this file. Okay, and then we can call this as what? Maybe we can just call std.grid. Okay. Okay. So we'll be using this one to remap. Okay, so if you are working with models, maybe you want to regrade your data, it means this one, you'll be using this one to regrade your data. You can also regrade your data directly using that Mela file. But sometimes if you want to be transferring, it will be just feeding your computer. It will be feeding your computer. So we generate this file because this file is at least smaller in size. Okay? So it's much more easier to transfer this one. So this one will be like your standard for regrading all your data sets. Okay? Yeah, so now we can regrade our data. Not so. So how do we regrade CDO? Then what? We are using biennial like the one we used last time. So we have to remap with what? Remap beer, okay? So remap beer, okay? Then what? That grid file, okay? So when you write a comma, that file sometimes doesn't come, but first you should write and then put a comma here. Okay, then which file are we regrading? The one we just cut, not so. Yeah, the one we just cut, written Africa. So we have to regrade this one. Okay? And then you can rewrite it maybe Afri, maybe graded. Graded, okay? .nc. I'm trying to move a little bit faster because of time, so that we can cover that. Okay, so first regrade, try to regrade. I'll wait for you there until you regrade your file. I'll wait for you until you regrade your file. Which one? Oh, you forgot something. CDO. There is no CDO between this and this. Yeah. So you can just do like this. You can just recall it and then put CDO there. I'll wait for you until you succeed to regrade. Have you regraded? Who has regraded? Oh, okay. Can you try to check the resolution of the data after regrading? Huh?
It's like yours gave an error.
Minus what? Has an error?
I'm seeing some warning.
Yeah, just disregard those ones. Don't mind those. Don't mind those errors. It has regraded? Have you regraded your data? Okay, let me see CDO info. Yeah, I have also regraded my data. So now it's also from minus 28 to 60. 45 to what? To 45, not so. So I have regraded my data. Okay? So from there now we can do our mathematics, whatever we want to do. We can do, we want to do some evaluation metrics, like maybe you want to calculate you want to compare the means, you want to compare the standard deviations, whatsoever. Now you can do all the processes, whatever you want to do, because your data is comparable to the other data. It has the same grid resolutions. Okay? Yeah. So there is something we need to do, okay? There is something we need to do with this data. So the data in Mela, okay? In Mela, the values are in microgram, okay? Microgram, okay, we write like this. Microgram per cubic meter. Okay? Microgram per cubic meter. So those are the values in Mela. Okay? In the model graded, okay. So the units in Mela I did not modify, I'm sorry. I did not modify, but the values are in micrograms, but inside it will show you like it is in kilograms per cubic meter. No, this is, I did not modify it. I will show you later how to modify such things. Okay? But just understand that the units are in this one. But in this one, in graded, the units are in, can you try to check the units? Kilogram. I think it's kilogram per kilogram. We already did how to check the units. For Africa graded. Yeah. It's in what? What? Kilogram per kilogram. It's just a mixing ratio. Okay, so first of all, we'll convert it to this one. So if the mathematics is complex, don't mind, it's okay. Don't mind, just know that we are trying to convert the data. So you can use such things to convert your data, okay? Maybe you're working with rainfall. Maybe next time I should bring some rainfall, like rainfall which is in maybe kilograms, or maybe which is in kilograms per watt. How you can convert those things, okay? So I will try to convert this one to this one, so I will just multiply with the density. Huh? This one? After graded? Can I say?
Kilogram per meter cube.
Per meter cube.
Oh, kilogram per meter cube.
Yeah.
Okay, I know. Maybe can you check the one for Mela? CDO? Or first, or either can you display those ones in GrADS and see the values? Display in GrADS. Do you remember how to display those files? Just display Mela and also display for Africa. Just display it in GrADS and see how it looks like. Huh?
The same unit.
Yeah, I know. After grading, it has taken the units for this one. Yes. Can you check the one for Sesmo? Can you check the one for Sesmo? The one for Sesmo. SE. Yes, yeah.
How we can know the unit of FI?
CDO show unit. Yeah, CDO show unit. Can you try to display in GrADS all the two files? Can you try to display in GrADS? Just display in GrADS all the two files. You display the first one, you see the values, and display the other one, you also see the values. Eh? Yeah, you see this one. So these are the units inside the data. But when you are grading, it just picks everything. Maybe just a small clarification, when you are grading the data using that file we generated, it will pick some attributes from the when you are, for example, you are grading, like here, we generated this file, okay? Not so. From std.grid. So things like lat, labeling like lat, loan, okay? Units inside the data. It will pick for this one. It will pick for this one, okay? So for example, if the original file was written latitude, full name, it will change to loan. If this grid file was loan, it will change the name. It will no longer be longitude, it will be loan. If the units were in kilogram per kilogram, okay? It will pick the units for this one. For this file, we have what? We have given. Because when we are grading, we are saying, can you pick all the attributes from the grid into the new file we are trying to regrade. Okay? So if you check the units we started with for SESM, they will be different from the units that we are ending with in the AFRI graded. If you do CDO info, they will be different. Okay? It will pick for this one. However, the values inside the data itself have not changed. So we need to what? To recalculate them. Are you getting what I'm saying? Can you understand? Okay. Let's go to GrADS. Let's go to GrADS. Yes. Let's go to GrADS. Where is GrADS? Geos open. Okay? We are in GrADS. how do you open files in GrADS? Is you already learned GrADS? Okay. SDF. SDF open space, then we should open that file also. So let's first open this graded. Okay. Let's open this file. Oh. Same problem? Same problem? Eh? Are we finding the same problem? Who is able to open? Who is able to open the file? If you are able to open the file, maybe either your file has a problem, or if you are able to open the file, either your file has a problem, or you have played around with the file. So you remember we faced this problem before. Okay, so actually this is how you'll be, these are the things you'll be meeting when you're doing your research. So how do we solve this problem? Eh? How do we do? You remember we faced this problem before? Yes, so let's change the calendar to what? To standard. You remember? Okay. Okay, so let's go, we'll do it in CDO. Yes. Yeah, I don't know if in GrADS it's possible, so those who teach you GrADS, they will show you. Okay, so let's do what we were doing last time. Let's go back in CDO. So we do, you know, these things are very common, okay? If we are not careful, they are very common. So most of the times, it is good that when you just get your data, first see which software are you using. If you are using GrADS, okay, check, is it able to do? If it is not able, then first correct that mistake at the beginning. Okay? But for us, we didn't mind, so that's what happens. So we have to correct it now. So we change it to what? Okay, so CDO, set calendar, comma, standard, okay? Then our input file, this one. So how should we call it? At least just call it Afri standard. So that we know that it's standard calendar, okay? Then see. So we'll be moving with this file. So we'll be moving with this file. Okay? So we can, okay, I'll wait for you. So you can see there's two softwares that are working hand in hand. Here you process the data, there you display. Of course, there are some things that you can just do them right away, all of them in GrADS, like setting large loan, what, those you can do them in GrADS. But assuming you are comparing your data, it means such things you have to work them right away in what? In CDO. And actually, one can just do the entire research, okay? You can do the entire research using two softwares, this CDO and GrADS. You are done with everything. You can do your study domain, everything, data processing, protein time series, anomalies, everything. Just two softwares. But you have to be good in doing them to produce some good graphics. Okay, let's proceed. So let's check it in GrADS again. You can first reinitialize, re-init. I hope you know this one, you remember this one, re-init. To clear first of everything you did before. You have to re-init. So we'll be moving, don't forget what you learned before. If you learned about GrADS, don't forget. So we are moving to GrADS, we are coming back. So it's like we are twisting our mind. So remember them. They are very important. Okay? And it was good that we started with GrADS. Okay, so let's display it again. CDO. Sorry. In my mind is CDO. SDF open. So we are displaying which file? Free standard, not so. Okay, so we are displaying this file. Okay, now it is working. Good. Okay, we can just set. First, let's query the file. UCTL info. I hope you already know these things. Set display color white. Okay, then see. Then you can display. Okay, let's display a shaded graphic. Okay, set what? Checks out shaded. Okay. Then we can display this variable. You remember which variable we display in GrADS? Okay, this one. Okay. So we just do D. Okay. We display. So you can see the values, they have exponential. You can see this is just only one time step. Okay? The first month of 2010, first time step. You can see, okay, sorry, one thing. Let's put the car bar. C bar. So can you see the values? The values are what? 4.5 to the exponential what? You see? Now, let's display that one for Mera. And we see. Let's display that one for Mera, we see. Okay? Am I twisting you again? Okay, I'll wait for you to display first. Yeah, first of all, display. But what we are meeting here is exactly the same we'll be meeting when you are doing research. And actually here in this school we are very lucky that we have these trainings, because somewhere you struggle by yourself. You don't have such trainings. Huh? Oh, this one. Oh, okay. There's a few commands that I had put. Set calendar. Missing inputs. I've regraded. What is your output? What is your output name? No. Just a second. When we are setting calendar here. Oh, here, it is here. Oh, my screen is small, so it is shifting to the other side. My screen is small, so it is shifting down here. It is here, yeah. Do you have a problem?
Nothing. What's wrong with your missing output file, right?
Yeah, you did not put the output file. You can just put free standard. My screen is small, so it cut. Should we proceed? Should we proceed? I will just do the same, but now for another file, for Mera. I just want you should appreciate these values, okay? I just want you should appreciate these values. What are the values in Mera, and what are the values in... Yes. So let's open now for Mera. Now we have to re-init this one. Re-init again, okay? So SDF open. For Mera is what? What's the name for Mera? What's the name for Mera? This one also. Yes, let's open that file. So okay, SDF open, and then it's Mela, this one, 2010-2014. Okay? So let's open that one. Okay, QCTR info. Why am I querying first? Why am I'm doing query the file? Why? Why is it that I'm doing that? Okay, remember what we learned in GrADS, okay? Yes, because you have to understand what will I display later, because if you don't know what will display, it will be very difficult for you. So first you have to query the file, see what is the information inside. This sounds more like CDOS info, okay? This sounds like CDOS info because they are the same things we are seeing them there. For example, you can see them here. We know them there's in GrADS. Okay, I will not explain them much. That's not I'm not an expert on that. But they are the same things we are. But here I'm interested on this one. Is the one that I will display, okay? So I can set again. Set display color. White. See. Set it. I want shaded. Yeah? Hey, you people, you are experts in GrADS. And actually, I have observed that those people who work CDO with CDO, they also know much better about GrADS. Yes, they know much better about GrADS. Those who work with GrADS, they know much better about CDO because you work them hand in hand. Here you process, here you display. You process, you display your results. Those who work with Python, NCL, not much with CDO because they will tell you that, no, I can do everything in NCL. I can do everything in Python. But if you are not good in coding, that's why we jump to CDO. Okay, so I need to display D what?